Hi friends, welcome back. Now we have seen how FM is generated, and after transmitting this FM signal to the other end, we receive the FM signal, and now it is time to get back or recover back our original message signal, and that process is called FM demodulation. In FM, that is frequency modulation, the frequency was made proportional to the modulating input, and now in FM demodulation we need to reverse back. We need to get voltage which is proportional to frequency. In the first case we had created a sinusoidal whose frequency was made to vary in accordance with the input voltage. Now at the other end we need to recover back this voltage, and hence we should somehow make sure to get this relation where voltage we generate should be made proportional to frequency. And most of the time when we were working on frequency voltage, we had used something called a tank circuit. And if you look at a tank circuit a little detail, it's basically a resonant circuit because they are in parallel, so we call them a parallel resonant circuit. And the response of a parallel resonant circuit, the output voltage or the voltage across the circuit, varies in accordance with the frequency, and it is going to be highest at the resonant frequency. And as we move away from the resonant frequency, the voltage across it keeps reducing, or in other terms, the impedance of this circuit will be maximum when the frequency is resonant frequency, and as the frequency deviates from the resonant frequency, the impedance of this keeps changing as per this bell-shaped curve we find. And the first thing comes to mind is, can we use this property for converting our frequency to voltage? So what we are trying to do here is frequency to voltage converter, whereas here we had done voltage to frequency conversion. Now, can we make use of this? Yes, of course, we can make use of this. So let us define this circuit, and let us look carefully into this shape, and we can see a part of the shape appears to be almost linear. A part of this shape appears to be almost linear, and if we can make use of this linear part of it, and if you can make your frequency deviate in this range, then the output of this definitely is going to vary in this range. So if we have some circuitry where we have a tank circuit, and then the property of the tank circuit is having impedance in this shape, and if we can make use of this circuit as part of our amplifier, then whatever input you apply, Now, depending on the frequency of this input, the impedance of this keeps changing. The impedance of this keeps changing, and in our common emitter session, we had seen that the output, uh, that is the voltage gain, depends upon this RC or the impedance used at the collector. And as the impedance at the collector is linearly changing in this region, that means if we can have the frequencies from say f1 to f2, that is what we had created for our input variations. For these variations, if we had created the variations from f1 and f2, then we get this as a output of fm, and if we feed it here, then the impedance of this keeps changing in this region, and hence the impedance of this changes almost linearly, and therefore we can predict this output changes linearly with respect to frequency. So in all, what is happening is the input frequency will decide the impedance of the tank circuit. Impedance of the tank circuit will decide the voltage gain of the amplifier, and voltage gain of the amplifier in turn decides the output voltage what we get. So the more frequency, the more impedance, the more impedance, the more gain, the more gain, the more will be the output. So we have converted simple frequency modulation into something called amplitude modulation, and we of course know how to convert amplitude modulation back to our signal, so am detector can be used after this. So this circuit is a simple one which converts the fm signal into am. So we have fm here and we get am here, and this am can be applied to am detector, and then we get our original signal recovered. So that's one simple way of getting the fm demodulation. So many more to follow. Till then, take care, see you, bye.